In section 5.2, we're starting to graph our polar equations. Remember, if coordinates are given to us in polar form, that would be r and theta, where r is the radius, theta is our angle. So on number 1 here, we have r equals 3. So really what we're saying is that our radius is equal to 3. We aren't given any other information here, so at this point we're just thinking that the origin would be our center point, and then the radius is 3 from there. So I could go 3 this direction, 3 here, 3 here, 3 here, and so then we have a circle with a radius of 3 for that graph. Now remember, we can also rewrite this equation into rectangular form. Now r, that doesn't really help us any, but r squared does. So if we multiply both sides, or if we square both sides, then we would end up with r squared equals 9. Now r squared, we know that's equal to x squared plus y squared. We have that from the Pythagorean theorem. So x squared plus y squared equals 9. That's a equation for a circle. That's our equation here where we're saying that our center is at 0, 0, just like we had assumed at this point, and that the radius is equal to 3. Now over here, we're told that theta is equal to pi over 4. So at this point, we just know that we have an angle of pi over 4. So what that would look like is we have a ray here where now we have our angle of pi over 4. Now there's nothing saying it's going to stop at the origin, so it would actually continue. So again, if we were to rewrite this, we know what that looks like. That's a line, and it's a line y equals x. So if we're trying to get that direction, first of all, if we were to, say, take the tangent of both sides, tangent of theta and the tangent of pi over 4. We know the tangent of pi over 4 is equal to 1. We also know tangent of theta, as far as rectangular coordinates go, that's our x and our y. So that's x over y, multiply both sides by y, x equals y. That's the rectangular equation for that line. Now if we look at example number 3 here, we have r times sine of theta is equal to 2. Now again, if we think of this as trying to write it in rectangular form, r times the sine of theta, that's equal to y. So we could rewrite this as y equals 2. We could actually do the rewriting into rectangular form first, then graph. So we know y equals 2. What that would look like, we have a coordinate plane. Where is y equal to 2? Well, we go up 2. And all the points across here, then y is equal to 2. So that'd be our graph for this as well. Same idea over here. If we rewrite into rectangular form, first thing I would do on a problem like this would be multiply both sides by r. Then we would have r squared is equal to 4 r sine theta. We know r squared is equal to x squared plus y squared, and r sine of theta is equal to y. Now we can subtract this over, so we have x squared plus y squared minus 4y equals 0. Now that's starting to look like our equation for a circle. Remember, we did this at the beginning of the semester. Our x squared, that's fine the way it is. We're saying that we have our x coordinate at 0. Y squared here, what we need to do is complete the square. So we have y squared minus 4y plus some value, and then we're going to have to add that same value on this side. Remember, what we're trying to do is get y minus some value. It's a quantity squared, so we take half of this, and that's what this value is going to be right here, is half of that, and then we square it to figure out what we're adding to both sides. We still have our x squared over here, and that's equal to 4. So there's our equation of a circle. Remember, equation of a circle is actually written in the form x minus h squared plus y minus k squared equals r squared. In this case, we're saying that h and k, which is the center, on this problem would be 0 and 2. That would be our center. And then r is the radius. And in this case, r squared is 4, so r is equal to 2. So now if we're going to graph that, we can go back up here to our graph. We're going to count off some points. And so the center's at 0, 2. That'd be here. And now we've got a radius of 2, so if I go up 2, down 2, over 2 from our center point there, and over 2 from our center point there, that gives us the circle. And that would be our graph for r equals 4 times the sine of theta. For this next problem, we have r is equal to 2 plus 2 times the cosine of theta. So what we're going to do here, we're going to go back to making tables. So we're going to have our angles be the different variables that we're plugging in here. We're going to use our unit circle, and we're going to go through, and first of all, it's 2 plus 2 times the cosine of the angle. So if I take cosine of pi over 6, I know that that is square root of 3 over 2. It's a value on our unit circle. And then next one, we're going to have 2 plus, this time I'm plugging in cosine of pi over 3, so I have 2 times 1/2. For this one, we have 2 plus 2 times the cosine of pi over 2. That's going to be equal to 0. Here we have 2 plus 2 times the cosine of 2 pi over 3. That's equal to negative 1/2. And then here we have 2 times the cosine of 5 pi over 6. 5 pi over 6 is equal to negative square root of 3 over 2. And then cosine of pi is equal to negative 1. So what we've done now is we're finding these values. This is going to be, when I multiply this out, 2 plus the square root of 3. Here this is going to be equal to 3. This is equal to 2. See, 2 times 1/2, that gives us a negative 1, so 2 minus 1 is 1. Here we're going to end up with 2 minus the square root of 3. And then here we end up with 0. So this just makes up the top half of our unit circle. We also want to do the bottom half just to make sure that everything's nice and neat. So next thing I want you to do is make a table and then go through and do the same thing for the bottom half of the unit circle, and then we'll check our answers. Okay, so here we have our angles: 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Plugged in the values for cosine of each of those angles, and what we end up with then is our 7 pi over 6 value is also equal to 2 pi, or 2 minus square root of 3. Our 4 pi over 3 value is equal to 1. Our 3 pi over 2 is equal to 2. 5 pi over 3 is equal to 3. And then 11 pi over 6 is again equal to 2 plus square root of 3. And then 2 pi takes us to 4. Alright, so next we're going to go through and we're going to graph each of these values. So now when we go over to the graph, let me back out a little bit here. So now here I have a polar graph, and we're going to plot each of these points. So as I work my way around, of course I know this is pi over 2, here's 0 and 2 pi. So we're going to go around and mark our coordinates, mark our graph. So we're going to have these angles, and then we'll mark off from there. So as I plot these points, first of all our angle, pi over 6, so I know it's coming off this direction, and then we have 2 plus 2 times the square, or 2 plus the square root of 3. If I find our decimal value here, we have 2 plus the square root of 3. That's about 3.7. That's our radius. So I'm going from the origin, here we go towards pi over 6, and we're going 1, 2, 3, and this is 3.7. So it's going to be about there. Now if I go to pi over 3, that gives us a 3. So here's 1, 2, 3. That'd be this point right here. So our angle is pi over 3. Our radius is 3. We've counted that out from the origin. At pi over 2, our radius is 2. So now I'm going up 2 to that point. Next we have 2 pi over 3 is our angle, 1 is the radius, that's going to be right here. And then we have 5 pi over 6. Let's see, 2 minus the square root of 3 gives us about 2.6. So from here going towards 5 pi over 6, only going about 1/4 of the way. Then at pi we're at 0. Now coming back around, 7 pi over 6 we said was again equal to the 2 minus the square root of 3. So we're going towards the 7 pi over 6 about 1/4 of the way. Then we're at 4 pi over 3, and that takes us back to 1. So here's our 4 pi over 3, back to 1. Now we're at 3 pi over 2, takes us to 2. 5 pi over 3, and we are equal to 3 for our radius. So I'm going 5 pi over 3 and counting it out, 1, 2, 3 to this point. And then at 11 pi over 6, we're back to the 3.7 value that we had before, where it's 2 plus the square root of 3. So 3.7, that's towards our 11 pi over 6. 3.7, so here's our 1, 2, 3, 3.7 is about there. And then at 2 pi, we were at 4. That's also our zero graph, so 1, 2, 3, 4 there. So what this graph ends up looking like when we connect it, it's curving as it works its way around, and it's going to curve here, comes into the origin, and then curves back out as it works its way around. And so that would be our graph for r is equal to 2 plus 2 times the cosine of theta.